Alright, after summarizing the information, the next thing is simply to identify the three key elements: objectives, decisions, and constraints in this problem. Based on the description, we can summarize that the objective is simply to maximize the company's profit. But how do you make a profit here? Well, we need to produce products and sell the products, okay? Tables and chairs. The company can sell any table and chair it produces. So that means the decision here is simply the number of tables and chairs to produce. However, producing them uses production hours from the carpentry and PMV departments. And there are only certain number of production hours available. So that tells us there are two constraints. The production hours from each department cannot exceed its available hours. Once we know the objective, decisions, and constraints, we need to translate them into mathematical language. This starts from defining the so-called decision variables. Decision variables are variables that represent the decisions you are making. And this decision must be a number. So in Flair Furniture Company examples, since we know the decisions are the number of tables and chairs to produce, we're going to use T to represent the number of tables to produce per week, and C to represent the number of chairs to produce per week. Also, you can use any symbols to define your variables, not necessarily using T and C here, okay? You can choose your own variables. Choosing the correct decision variable is absolutely critical. If you don't choose the right decision variables, the chances are you won't be correctly formulate the problem. And I need to admit that actually sometimes the most challenging part is choosing the right decision variables. This takes time, experience, and as you see more problems, you will become more familiar with it. Also, you may need to define many decision variables, not just two. You will define as many decision variables as you need to formulate a problem. And also, just a reminder, you need to be very clear in terms of the definition of the decision variables. You need to very clearly define your decision variables. For example, you cannot just say T equal to tables or C equals to chairs. Okay? If you do that in the exam, you'll be taking points off because no one really understands what that means. So I want to emphasize again, when you define decision variables, they need to be very precise. Okay, once we define the decision variables, next we are going to use them to represent the objective and constraints. I also have the information summarized on upper right. The objective is to maximize the company's profit. So we need to express the company's profit in terms of our decision variables, T and C. We know each table makes $70 in profit. So if we make T units of tables, the total profit from tables would be simply 70 T. Likewise, the profit from making C units of chairs would be 50 C. So as you can see here, our goal is simply to maximize the profit, which is the sum of 70 T plus 50 C. Next, let's formulate the constraints. The first constraint is that we cannot use more than 240 hours of carpentry time. So how do we represent this constraint in a mathematical expression? First, each table needs 4 carpentry hours. So if our decision is to make T units of tables, that means we need 4 times T carpentry hours. Okay? Or in other words, 4T here is the total carpentry hours from making tables. Likewise, each chair needs 3 carpentry hours, as the table on the upper right shows. So if our decision is to make C units of chairs, that means we need 3 times C or 3C carpentry hours. So here, 4T plus 3C is the total carpentry hours we use for any given number of tables and chairs we choose to make. We know this number cannot be more than 240. So mathematically, this simply means the total carpentry hours used, 4T plus 3C, should be less or equal to 240. So that's our first constraint. The total carpentry time used cannot be more than 240 hours. The second constraint is the hours of painting and varnishing time used cannot exceed 100 hours per week. Each table needs 2 P&V hours, so making T units of table will require 2T of P&V hours. Each chair needs 1 hour from this department, so making C units of chairs will require just 1C of hours from this department. And again, the total hours used in this department cannot exceed 100 hours, so that means 2T plus 1C should be less or equal to 100. There's actually one more constraint that is not explicitly stated in the problem. That is, the number of products produced cannot be negative. It just doesn't make sense to make, say, -1 tables, right? So we have another constraint here, which is simply T and C must be greater or equal to 0. You can produce 0 table or chairs, that's fine, but you cannot produce negative tables or chairs. Just as a reminder, in this course, we will assume all decision variables are non-negative. So in other words, you will always have this non-negative constraints in any problem. Now that we have mathematically formulated objective, decisions, and constraints, let me tell you how to formally present them. We will present a problem starting with your objective. In this problem, we are trying to maximize profit, so we have max over here. If your objective is to minimize something, then you will write min, M-I-N, instead. Here, 70T plus 50C is called the objective function. Next, you will show all the constraints. Here, we have ST on the left. It is short for subject to. It means that our decisions are subject to the following constraints. I just want to remind you that every problem either tries to maximize or minimize the objective function. So you will either have max or min, definitely not both. Also, you may have more than 2 decision variables. In this example, we have only 2, but it's actually quite likely you will have more than 2 in practice. Finally, it's possible that a decision variable does not show up in the objective function. Okay, there's nothing saying that every decision variable need to appear in the objective function. If it doesn't show up in the objective function, you can simply see that as the coefficient is 0 for that decision variable.